Hello, everyone, and welcome to the webinar. My name is Ben Reed, and today we have an exciting conversation today about heat pumps and airflow. And so with me is the fine Joe Medosch, our Director of Training. He will be moderating the discussion. And we will be discussing the design elements and a lot of the implementation elements of how to get airflow correct when dealing with heat pump installations or retrofits. And throughout the webinar, if you have any comments, if you want to participate in the discussion, you can use the chat function in YouTube. Throw in whatever you want to talk about in there, and we'd love to hear from you. We'd love to throw your comments up on the screen. And with that, I'm going to hand this over to Joe, and I will come back at the end of the webinar.
All right, thank you, Ben. Well done. So the first thing I wanted to try and bring up was the concept of what, if Jim was doing this webinar, that he would give you a overview of some basic math. So if you could throw that slide up, that'd be great, Ben. So this is what it's like when you go do a measureQuick training with Jim, is that he's got a variety of math that goes along with that. There we go. That's it. Great. So here's what Jim does with a measureQuick class. It takes a while to press buttons. We are focused on, do you understand some principles? And he make sure you understand how you got a CFM out of that register. How much CFM do you need based upon BTUs? That goes back to design. That goes back to pounds of air. There's a variety of stuff that's going on with how to make sure that you have the right airflow that's intended for what you have as your system. That of course starts with a really good design. So today we're not going to talk about airflow in terms of measuring it. That'll be a whole nother kind of topic and a great one to have with others. But we're talking about, do I able to have a great design, and am I able to get the airflow that I need? How much airflow do I need? How do I know that that's going to be pertinent for multiple homes that may be dealing with a production builder, or for this one client, retrofit? There's a variety of stuff that comes into here, and it's not just the ducts. It's also, how does it get into the room and how does it move throughout the room? So today we've got some great guests that are actually figured out how to design this stuff. I know Russ has gone everywhere from installing them, designing them, fixing them, and then figured out a way to actually create software to make it easier for you to figure out these solutions. And we got Greg Kula from Jones Services out of New York, who has had hands-on experience doing these things, finding these problems, and working with clients to make them understand as to why they need to put this duct work in certain places. So we're going to go through some of those. But what always makes these webinars great is you, the listener, is to please chime in, give us your feedback, give us your horror stories, give us your questions, let us know what it is that you are having either challenges with or successes with. All those kind of things make the whole webinar dialogue excellent in the background. So as you can briefly see on my screen here, that we're talking about the BTU concept, and that actually goes along with doing a great design. Your manual J, if you do a block load, it's a little more difficult, but when I do room by room load, I can actually determine how much BTUs and CFM would actually be required to make this room, meet those loads. Not everybody's doing that. The block load gives me an overall CFM, and then I kind of can people figure out a way to design what they need to for those rooms. So some other stuff that we're going to talk about is, what comes out of the register, where the register should be, what kind of rooms you've got, in conditioned space, not in conditioned space. And we got a few slides to kind of take you through what that experience is, and some horror stories from Greg as to when this didn't really work right. So I'm going to bring on our guests. So I'll have Greg and Russ come on in, and they will kind of give an idea. I usually don't try and, we all have this little bio that we have for our webinars, and I really don't like to read those things, so they just sound kind of dry, or I'm not doing that. So let's just start with Greg. Greg, why don't you just tell us where you're at, what do you do, and what's your process in terms of what we're talking about for airflow.
Cool. Well, I'm Greg Kula. So I started my career here at the same company. Been with the company about 9 years, almost 10 years now. Started right out of college as a maintenance tech, installer, service tech. Then became service manager for a couple years. Now I'm focusing more install manager. So right now my responsibility is more, our sales team goes out, sells a job. whether it's just a replacement or a brand new cut-in. Then I'm pretty much doing all the engineering stuff on the backside. So figuring out what size system, what size ductwork, and what we need to do to make that customers happy. So right now I believe I have 9 install crews under me for HVAC install. And then I also deal with our 2 electrical install crews too, doing the service upgrades and generators as well.
All right, Russ, how about you? Tell us about your life story.
Yeah, we don't have enough time. Yeah, my first job out of college was doing energy modeling calculations and manual JS&D calcs, and that was before we had computers. Before we had software to do it, we actually used worksheets to do manual JS&D, and you had to fill it all out by worksheet, and then your boss would come by and say, "All right, now do it with better Windows." And you're like, "Oh crap!" So you had to completely start over. Well, now you can just type in a number and get a brand new load calc instantaneously. It's pretty amazing. But one of the things I like to say about computers is they help you make bigger mistakes faster. So you do have to be careful. Software is not the end all be all, but so I ran several mechanical engineering departments in my career that specialized in residential production homes. I have several thousand plans under my belt that each of those plans was built 20, 30, 40 times. And so there's a lot of houses out there. Did a lot of work in California, Nevada. Probably about a third of the houses we did were in Las Vegas. So very familiar with hot, dry climates. And then I used software my entire career, was never really super happy with it. And then about 5 years ago, my son graduated from college with a computer science degree, and he wanted to design video games. And I was like, no, I've got this idea. Let's try it out. And so I basically hijacked his career and convinced him to write a software program. It's a manual JS&D load calculation software that's written in a video game platform. So it's 3D, looks like a video game, feels like a video game, but it's legit. It's ACA certified and all that stuff. So it's called Quick Model, and we're very proud of it. And our company is called Coded Energy is the name of the company. And so my son and I, we're running it, and off we go.
So I know that the gaming industry is making billions of dollars. So I'm sure that you guys are also making billions of dollars off your software. That if you haven't seen it, we'll have some links that we'll pull up here in a few minutes that kind of give you an idea to where to go. And there's plenty of stuff on training and stuff on YouTube, but it actually is able to literally draw in 3D and actually design your ducts as they would actually exist in that house, whether they were inside or outside conditioned space. Everything's being calculated, but the fact is you can see it in 3D is really what's exciting and allows a lot of people to make this a primary choice, because I understand what the ducts are and come up with all my fittings and everything rapidly versus lines on a spreadsheet that really don't actually answer that stuff. So
yeah,
one of our focus is going to be on heat pumps is part of this conversation, because airflow is critical for heat pumps. So I know there's a variety of discussions we wanted to go with, but Greg, I'm going to come back to you with this concept we talked about. Okay, so I got a design, it's on paper, I got a list of some fittings, and then we go to the house and there's some modifications or whatever. But talk to us about some of the challenges and benefits of actually knowing this ahead of time as to what I'm going to do in the house, from paper to actual install is what we're after.
Yeah, I think the biggest thing on just any type of design that we end up doing is bring the customer in the loop first. Because what I end up doing, all our brand new systems that we are just cutting the holes in the sheetrock, going in, putting a brand new air conditioning heat pump, whatever we're doing, really just bring the customer in to see what their expectations are and try to match it as best as we can with our design. So some things that I've seen over the last couple of years of doing this is, will the customer want a big return grill in a central part of the house, a hallway, a living room or something where they're going to see it all the time? Is it a focal point when you walk through the front door is a big concern of a lot of customers. Even just where the outdoor unit's going is a big concern. Can you see from the street? Are you going to hear it when you're on the patio or whatever? So a lot of it is just bring the customer in the loop. I try to do most of my engineering where I go out to the job site before our installers are even there, so we can make this decisions, have these discussions with the homeowners. So when our team goes there, they could just go to work. They don't have to start planning and have to redo anything.
So at my in-laws' house, they realized that they needed to upgrade their system, and their entire attic is the only place where they could really, swap out the poorly designed duct that was there that's just way too small to something larger. And they have all of their life belongings, Christmas chairs, furniture, everything. So eh, I'm going to ask you to just kind of go through as though we were your client as to why it is that we need not just access, but how you need to run your ducts to actually get that. And you're going to get some pushback as to no, 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 no. This stuff's fine. You can just run your ducts around it. I know that stuff's flexible. So give us a shot.
It's funny you mentioned that. It's funny you say that too, because we just had a customer a couple weeks ago. She inherited the house from her father. Her father was a collector before he passed away. So I go to the house to do my pre-install walkthrough just to see where we're going to run the ductwork, how it's going to look, and open that attic hatch, and the attic is packed full. And she's, ordering a dumpster, and said at some point she'll get it out of the attic. So even that we took into consideration. Like, do we have a set of guys that we could send there, whether we charge or not for it? Can we help her clear it out so we get that job done quicker and get it done the right way, so we're not working around stuff? But a lot of the time we start to struggle, like, if there's a lot of storage up there, can we run our ductwork in certain areas where they're not stepping on it, tripping on it, setting boxes on it, crushing it? And is there a way that we can run it without going up and over the rafters? If we're right on the rafters, we're going to get a lot hotter temperature, and it's going to affect the system rather than running it on the ground. So there's a lot of stuff that we try to bring into account when we talk to our customers.
So Russ, I'm sure you've had similar issues with homeowners stuff, but there's also just issues with the design. So people will have these cathedral ceilings, and they're like, "Yeah, I want some air over there, and I want some air over there," and you wonder, well, how are we going to get this without actually making a change or something? So why don't you give us some of the challenges that you've seen where the architect just never really accommodated for ductwork?
Yeah, it's a big difference between existing homes and new construction, where you're working from a set of architectural plans. Most of my career was new construction, and so I was always fighting with the architect. All I want is this little corner of this walk-in closet. Just please give me this little 12 by 12 corner. That's all I need to get the duct down to the first floor. And they're like, okay, sure. And then I get out there, and there's a floor joist running right through the middle of it, and you can't get the duct down into the floor joist on the first floor. When I teach the manual JS&D class and we talk about duct design, sizing ducts is actually really easy. Getting them to fit in the house is the hard part, especially, probably 2/3 of the houses I designed were 2-story houses with the horizontal units in the attic, and you're trying to get through the second floor down to the first floor and then run through the floor joists. I had one builder in Las Vegas who used 22-inch open web floor joists. It was a dream. It was like you could run ducts anywhere you wanted to. There was no restrictions. It was beautiful, but that was just one builder out of 50 that we worked with. Getting ducts to fit is always a big challenge. And then in existing homes, it's usually not too bad because there's already a duct system there. It's just a matter of, can you make it bigger? Probably, usually is what you want to make it bigger. Typically the ducts are undersized. The equipment's oversized. The ducts are undersized. I think there's a huge potential for existing homes. It's the classic low-hanging fruit out there just waiting to be picked. And there's so much improvement we can do on existing homes right now. I mean, I've seen houses. It's just scary what's out there right now. I've opened up, the furnace, the return grill below a furnace in a hallway, and there's a hole down into the crawl space. You can actually see down into the crawl space. There's stuff like that going on that we can fix and make it a lot better. So there's a lot. I haven't run into any hoarders yet. We're probably going to get to that point at some point. We use a phone app called Cubicasa. We need a set of floor plans for our software to work. We need a set of floor plans, and most existing homes don't have floor plans. So there's a really cool phone app called Cubicasa. It's free, and you basically point it at the baseboards, and you walk through and you videotape your baseboards all the way through your house. You send that file off, and they send you back a floor plan that looks like an architect drew it. It's phenomenal. It's really amazing, and it's free. If all you want is a basic floor plan, it's free. But I've had people say, well, I've got a room full of boxes. I can't even get into that room to videotape it. I'm like, well, do the best you can. And it actually comes back pretty good. If you can see part of the floor and part of the wall, it's sending a signal that's bouncing off, and it's finding where the edge of the wall is. So it does a pretty good job. But we've had a couple of times where they couldn't even get in the room. Like the door wouldn't even open. They couldn't get into a bedroom. It's like, all right, well, go around it. We'll figure it out, So, yeah.
So now that you have what you thought of as a great design, Greg, and you went to the house, and then you didn't really pay attention to one detail, and you come back and suddenly there's 390s back to back that are used to get around something that was kind of missed in the design. And so why don't you give us some challenges as to like, what did that just do to my airflow? What did it do to my design? And people don't think that these 90s have much impact, and there's an associated length with every fitting, not just the 90s, but even the boots and all that kind of stuff. So when you have people in the field that are changing what you guys had designed, why don't you talk about how that not just impacting what you're getting as airflow, but how do you educate your technicians or your installers as to why this is not something you can do without us kind of confirming what we're going to get out of this product?
So a lot of our installers and techs know that, like, if we have something we got to change, where day of we're turning wrenches and find that we got to add another fitting or something, if it's going to cause an issue where it's not going to work, our guys are going right to the customer, bring them right in the loop and say, hey, I cannot do it this way, but here's a couple different options of what we could do. Whether it's, if we're talking return side, can we split it into multiple returns, or just, move that return to somewhere else, even though it's not the best look for the home, but maybe that it's going to perform better, so they'll be happier. One thing, like even with our techs, I always say that if we do something a little bit less quality up front, we're going to own that. I'd rather own a customer being upset about the grill being there, they're going to notice for 2 weeks and then it just blends right in, rather than us put it where they want it and it not work for the next 10 years or 5 years. And how many times are we going back for $0 tickets and callbacks and complaints and whatever else, So I'd rather do it right the first time and move it if we need to, with the customer in the loop.
Yeah, the customer in the loop is, I think, a key there. That's great. So let's go to a technical issue that is, I think, is one of the most common things. So people are like, oh yeah, we're having some airflow problems, or this room is not getting the temperatures we need. And the easiest solution is to add an additional return. Right? They're like, oh yeah, we just need more return. We need better airflow. We need to reduce the this condition, and they do it, and they find it changed nothing. So Russ, why don't you explain that why just adding a return really is not always the quick and simple solution, because they find out all the other airflow didn't change at all.
Yeah, there's two sides to the duct equation. There's the return and the supply. And if your supply is grossly undersized, no matter what you do to the return, you can only cram so much air through there. But I typically find that the bottleneck is on the return side. There was a HVAC contractor, large HVAC contractor here in the Sacramento area, that learned at some point, they made it standard practice when they went into a house to replace equipment, they always added return capacity somehow. They just made it standard practice, and I guarantee all the noticeable improvement that the homeowners commented about was from that one thing that they did. Not anything else they did, was that one thing. But it can make a huge difference. But yeah, it's all about the supplies. There's several points in a duct system where the air has to go through. Like all of the air has to come out of the supply plenum. All the air has to go through the registers. And there's different points in the duct system that you can look at and evaluate just on paper and say, yeah, this is going to work or this is not going to work. If I can pull up a quick sketch, if that's okay. This is literally, I get asked this all the time. I have a blog. I get a lot of homeowners read it. And people will call me up and say, hey, Russ, does this look good to you? And they will sketch their duct system out on a napkin, and send it to me. Go, hey, does this look good to you? And you can actually evaluate it. It's not impossible to evaluate it. So let me share this really quick.
Wait, I know this illustration. I use your illustration in my presentations, and I actually superimposed it on a napkin.
That's awesome. Yeah, I was actually at a seminar one time, and this guy was talking about good systems and bad systems, and he goes, "Here's a bad system," and he pulled up my drawing, and I was like, "Hey, I drew that, but I drew it intentionally bad. It was supposed to be bad." So I get people sketch up something like this, and they'll say, "Does this look good to you?" And I'll say, "Well, first of all, what's the tonnage?" And they'll say, "Oh, it's a 3.5 ton." I'll say, "Okay, you want to move about 1,400 CFM, right? So all the air is going to go through the return." So that 16-inch, if you look it up in a table, a 16-inch is only going to move about 1,200 CFM. So you've already choked it off there. The other thing is that all the air has to go through these 10-inch trunks. And so you can look at those 10-inch trunks and say, is that enough? The other thing is that all of the air has to come out of these branches. And then you can add those up and tell if it's enough. So it's pretty simple. Just stuff like that is it's pretty simple to do. So, and if you make all the trunks too small, it doesn't matter how big the return's going to be. But you also have to realize that it is a continuum. If you imagine the molecule of air getting sucked into the return and passing all the way through the system and then coming out of supply register, at each point in that system, there's either more or less resistance. And when you make less resistance at any point along the way, it helps the whole thing. Okay. And so you can have one restriction, but you can compensate for that one restriction by making it bigger on both ends of that restriction. I had a weird situation one time where we couldn't get like a 12-inch duct to fit through a spot. And so we drew in our plans that it would go from a 12 down to a 10-inch sheet metal. It would go through this hole. It would come out the other side back to a 12. And the contractor saw it and he goes, "You're nuts. You don't know what you're talking about." And they said, so he just made it a 10 the whole way. He goes, "It's going down to a 10. So we're just going to make it a 10 the whole way." I said, "No, that's not how it works, because there's resistance there's less resistance in the 12. There's a little bit of resistance in the 10. They go back to 12 where there's less resistance, and it'll work. Trust me, it'll work." And so I had to explain the whole concept of, static pressure drop along the way as you go. And so there's a lot of complex things. It's not rocket science, but it's complicated, but it's also really easy once you figure it out, once you get used to it. The hardest thing to understand about duct sizing is the concept of friction rate. Friction rate's the first thing that's bad with friction rate is the name is bad. Friction rate implies something bad. Oh, that's a high friction rate. Well, what it should be called is available friction, or available, what's your friction budget? How much friction can you spend? That sort of thing. And then it gets a little bit easier. So
maybe it's how slick is it? How smooth is it? Yeah, something. I don't know.
Well, friction rate actually describes the system. You look at the entire system from return grill to supply register, and you can have a different friction rate for each run.
Yes.
But and the cool thing about friction rate is it incorporates your total external static pressure. Because when we say we need this much air in order to get this much capacity, right, for an air conditioner or a heat pump, you look in the expanded data tables and you change the airflow, it changes the capacity and the efficiency, by the way. So you need this much efficiency capacity. Sorry, you need this much capacity. In order to get this capacity, you need this much airflow. In order to get this airflow, you can't have any more than this static pressure. And that's determined by your duct system. And so you take that static pressure number and you plug it into the number that's used to size the ducts, so that when you turn on that system, you're not going to see more than that static pressure on the duct. So that's the really cool thing about friction rate, is it incorporates that into it. And then it also looks at how long the ducts are, how many bends there are, how many fittings there are, and all that other stuff. And yeah, you do a good design and you'll get good airflow. And then a lot of those other little things that people talk about just kind of go away. You don't have to worry about, exactly where you put the return and stuff like that. So, yeah.
Yeah, you make it sound just so easy, Russ. So thank you for that. That's right. Yeah, right. So one of the questions follow up for you is that, so didn't that little restriction become like an orifice, or that he described it as a friction like an orifice? Was that really what was happening?
It is. So but you take that into account. You factor that in. But what the contractor said, well, that's like the limiting factor for that air. Well, what it is, it's a pressure drop. but all the 12-inch before that had a lower pressure drop, and all the 12-inch after it had a lower pressure drop. And when you take that whole thing into consideration, it was much better to go from 12 down to 10 back to 12 than it was to be a 10 the entire way, if that makes sense.
Oh yeah,
So
yeah.
and
But
as long
it's
as you,
hard for others to understand that. It's the challenge, you know.
yes,
Yeah.
you have to like go along each point and say how much pressure drop is there. Oh, there's a big pressure drop here, but I'm going to go back to a 12, so there's less of a pressure drop as I go to the end. And
Yeah, I
so
think people think of this stuff as like engineered wood or stuff like if I had a a 2x10 and I went down to a 2x8 that didn't if I went back to 2x10 anyway, just that's kind of some of the analogies that we stuck in our head as these concepts that doesn't so
or like the weakest link in a chain or something like that.
yeah,
And it's
right,
and
right.
it's not. It's you have a budget to spend, and each foot you go, you spend that budget. And if you're spending it less along the way, you can spend more at this one spot and then spend less afterwards. I hope that
Yeah, I like the
helps.
budget concept. So, Greg, you're doing your designs for Joan. So I know one of the questions that many people ask is really how long is this taking you to be like, okay, let's do an existing house where you need to be a little more attentive and I can't look at a drawing to try and figure out what I got to do. So let's talk about an existing house. How much time are you guys spending on that and then coming up with my materials list?
Sure. So every house that we work on are pre-existing. We don't do any new construction. So every home we're going into are homes that are already being lived in. You got furniture and everything everywhere. So what we have our sales team do, I have 2 sales guys that are from the industry. 3 of them are not. 3 are from another industry that learned HVAC and learned enough to have a conversation. So as we go through it, or as our sales team goes through it, they know certain pictures and certain measurements to take. And then it comes to me. If I need anything more, I'll actually set up to go out with the customer and get some final numbers. So once I actually get all the information I need to sit down, it'll take me anywhere from 10 minutes to about an hour, depending how involved it is, if we're doing a mini split with multiple zones or just one zone. A lot of our homes are a little bit different, but most of them, we kind of know the area. Like certain areas will have a housing tract of all the same homes. So I know the layout just being around for 9, 10 years in these homes. So I'm able to go through it a little bit quicker. Anything that's more like contemporary or architect moved up from New York City, he built a house that is not the normal, then it takes a little bit longer. So during the summer, it definitely chews up a lot of time, but once we're into winter, spring, fall, we got a little more time to kind of put more effort into that design.
Got it. So I was going to share an image real quick, just kind of talk about newer homes and stuff we have. And I got my buddy Dan Bronco. I know you know him, Russ. We kind of do a presentation together, and he shares gives me a bunch of images to work on. So this is, you can tell by just the ductwork that this is not a 20-year-old system, right? But you go to the house, you're here now on a service call, and you look up in the attic and you see this. So what is your discussion with the homeowner about this? And again, this wasn't your install, or maybe somebody, it could be like, oh my God, how do we do that? But normally this is somebody else. You now do to explain to the homeowner that this person really should have done a better job of installing this. So you see this, what's that discussion look like as something you want to make better, and why?
Yeah. So a lot of the time too, it's talk to the customer and figure out, did it work beforehand? And Murphy's Law says as soon as we put something new in, it's not going to work. Customer always brings that up as, it worked before you were here, now it doesn't. So really that conversation is very important up front, but document it, write it down, keep it somewhere, have it on the invoice or wherever you want. So you could always refer to it and be, have that conversation of, hey, we talked about the ductwork and there was nothing that you noticed up front. So now we could fix it now. Or we talked about it, that room was always too hot, too cold, whatever it was because of ductwork like that. Now, we can update it down the road, see what happens right when we install the heat pump or air conditioning and go from there. Now, stuff like this, I'm sure some of my guys have done it in the past. Like sometimes you don't have any other option, but that's where when we're sizing the ductwork and planning what we're going to do, we could take that into account. Like this one, you could work around this easily. But if there was trusses in the way, a chimney in the way, something like that where you can't get around it, or maybe customer has storage that they don't want to give up or move, you got to figure out what we can do that will work, but still keep the customer happy.
Yeah, someone in the background, I was pulling it down. Someone in the background points out that they use the ADC, Air Diffusion Council guidelines for a variety of stuff. So, and that will bring us to one of our most common challenges is that, the flex duct installed correctly and following the Air Diffusion Council and the information that comes from the flex duct in the box versus, metal runs. I lived in Georgia where almost everything was a metal duct. They rarely used flex except for little connections that they needed. The problem was that they put stuff in a crawl space, and within less than 10 years, it rusted away. Like literally, the ducts were gone. You just had insulation with some rust inside. So, what is your? How do you explain to a contractor? You did it. You helped them with the design, Russ, and how do you explain to them that, if they're going to use flex duct, how do you make sure that they don't just use the whole box? Or know that they actually stretched it out and followed protocol?
Yeah, if you do a good manual D has a lot of safety margin built into it. Just as an example, if you need a certain amount of airflow and you have to bump it up to the next size. So let's say a certain size duct will only handle 100 CFM and you need 120 CFM. You got to go to the next size up. Well, that next size up might handle 160 CFM, but you've got to do that. You've got to go to that next size duct. So now you've got some excess capacity in that duct. All right. And so that gives you a little bit of cushion for a little bit of wiggliness in the ducts. And it's surprisingly, and this is all if you do a good design. If you do a bad design and you're a size too small, now a bend is going to have a big impact, because you're already too small and now you're making it worse. But if you round up a duct size, you've got some excess capacity, you put an unaccounted for bend in the duct, it just brings you back to where you're supposed to be, right? You're fine and you don't even notice the difference. I teach a class. I don't know if you noticed my hat, Casumas River College. It's the local community college here in Sacramento. I teach one class, Intro to HVAC, and we actually lay out a duct system on the ground. And it's got 10 registers in it. It handles about 1,000 CFM, and we lay it out on the ground, and we use a duct tester, a duct blaster, and we blow air through it, and then we bend the ducts to see what happens to it. So we were pushing 140 CFM through this duct system, and I said, okay, now go out to every single one of those 10 registers and put a big curly Q in it, like more than a 360-degree bend on every single register. Okay. And they did that. The airflow dropped from 1,040 to 960. That's not that big of a difference, considering they put more than 360-degree curly Q in every single duct. So if you do a good design, it's forgiving. It's a lot more forgiving. But if you do a bad design, those little things make a much bigger difference. And so, I tell people, don't make it worse than it needs to be. But if you have to put a bend in there that I didn't account for, don't call me up and ask me if it's okay to do that, because I've accounted for some of that stuff. So, yeah.
And so one of the other ones go ahead, Greg. Sorry. Yeah.
Even like when we're talking about design, like I got a lot of customers that are like, no, I had a 4-ton, I want a 4-ton, or I have a 3-ton, I want a 3-ton. But if that's not the right one for the house, it's just making your job as the contractor tougher, because now you got to size ductwork for a 4-ton when really the house only needs 2.5 ton. Mm-hmm. So you're able to save a lot of the trouble of trying to fit something in a place it doesn't fit by putting the right size HVAC equipment in.
Yeah. And it's a really tough sell to convince a homeowner to downsize their equipment. Yep. I was actually involved in a defect litigation lawsuit against a builder. I was on the builder side. The subdivision, the owners of the subdivision were suing the builder because they thought their equipment was undersized. And it turned out the equipment was actually oversized, and that's what was causing the problem. And I came in, I said, no, I did the load calcs. No, your equipment's oversized. That's the problem. And they're like, oh, BS. They didn't believe me at all. Of course, I was on the builder side, so they didn't trust me at all. But I finally had to show it to them on paper, and they still didn't believe me. I said, okay, fine. let's do some data logger tests. So I convinced their attorney to let me put data loggers in these houses. And the design temperature in this town was 99 degrees. And while I had these data loggers in the house, it hit 106 degrees outside. And those air conditioners were short cycling at 106 degrees when the design temperature was 99. And so I said, there, finally, do you believe me that this equipment is oversized? And it turned out that their problems were duct sizing problems. They had undersized ducts, and they had bad air balance. And their first thought, homeowners' first thought is, oh, it's too small. A bigger system will fix the problem. And no, it'll make it worse. A bigger system will make it worse. So yeah, it is a really tough sell.
Let's add one more complexity. So I have a image coming up here, in that is that somebody said in the back was that oversizing the ducts. Yes, they do the same thing I do on my phone, and think duct actually overrides it. It says if you oversize them, you can expose yourself to having too much temperature as a challenge with those. So so this slide is a twofold. It's if they are in unconditioned space, especially the attic, do I have enough insulation that just wraps around that? Is that enough to do that? And the other one is, let's talk about how to get these into conditioned space, which is a challenge for existing homes, but new homes, this is still a challenge to work with builders to be like, you know what, we can do this. You have room in the hallway, or let's design this to bring these into conditioned space and increase my ability. So I know you guys are in New York. So Greg, why don't you talk about where your duct systems normally are, and how are you dealing with exposures from cold temperatures when they may not be? I'm sure you still go to some homes and find out that, wow, this is in an attic, and maybe this is not the best place to be putting, all of my hot air in a super cold attic.
Yeah. So we got two options usually, is basement or attic. Honestly, most of the time I prefer attic, even though we're dealing with the hot temperature. Most customers don't care what you do. When I'm in a basement, most of our basements are barely 8 foot tall. Sometimes you get lucky, you get a 9 foot tall ceiling, that you have the room and it's not going to kill the headroom in the house or in that part of the basement. But most of the time we're dealing with 8 foot or under. So now by the time you're done with the ductwork, especially the return side, you only really have 6.5 feet, 7 foot, maybe set a little over 7 foot. At that point, customers don't want it. And it always lands right at the bottom of the stairs, or right where they're going to be walking most of the time. So me personally, I love doing attics, even though we're dealing with 150-degree attics or 20-degree attics. We just insulate. So right now we're doing everything R8 insulation. Hopefully they start coming out with thicker and better insulation. I've had conversations with customers before of maybe you encapsulate the attic, spray foam the roof. But by the time you see the price, the customer's like, nah, I'm good. I'll just let it be. But looking in the attic, like if we're reconnecting to ductwork for a heat pump, especially if it's old R4 insulation, R6 insulation, duct board that's disconnected and broken down, we're always offering it to replace. And it's a strong recommendation just to kind of CYA up front that the customer's not going to blame us for it not working.
Well, the one thing that I'm seeing in other parts of the country, hopefully you are too, is this concept of buried ducts, that they're insulated, and then they just pile on, either fiberglass or cellulose on top of that to try to get this separation in that. So there are potential condensate problems if you're not careful, whatever climate you're in. But you guys seen any kind of buried ducts for your attic, Greg?
Not too much. We do have a couple attics throughout the years where they're blown in cellulose, and you come out of the attic and you're covered in it. Our installers go up with snow shovels and just start moving it so we could get up in there and find where the ductwork is. But most of the time it's just fiberglass bats and then ductwork right on top of it.
Got it. What are you seeing are some of the newer challenges to deal with temperature exposures, Russ? I know most of California, you guys are like, wow, our temperature swing is so high, but you work all over the country. So there's a lot of stuff that's happening about getting better insulation in your ducts and separation.
Yeah. New construction in California is about as good as you can do, honestly. The energy code has gotten so tight. They're really looking for new ways to save energy in homes, and they're having to really reach. We have something out here called high performance attics, which is it's a vented attic, and the insulation's on the ceiling like it normally would be, but there's also insulation up against the roof deck. But it's a vented attic. And when I first saw that, I was like, that's stupid. Why that insulation at the roof deck's not doing anything, because it's a vented attic. Well, what it's doing is it's actually acting like, you've heard of radiant barrier. Think of it as super duper radiant barrier. It works even better than radiant barrier at stopping that heat from coming into the attic. And so the best case scenario you could possibly hope for is to have your attic temperature be the same as outside temperature. Right. But I've been in attics in Las Vegas where I went up in the attic and went, nope, there is no way in hell I'm going up there. It's like ridiculously hot up there, dangerously hot.
Dangerously hot. That's right.
Yeah. And so this roof deck insulation is an attempt to reduce that heat coming in. And then the next step above that is the encapsulated attic where it's an unvented attic, and it's usually spray foam. I've seen some where they'll hang fabric and then fill it with a blown in cellulose. But the point is that now there's no ceiling insulation. It's all at the roof deck. And so your attic is kind of a semi-conditioned space. I don't want to call it truly conditioned space, but that helps a lot too. I think crawl spaces are highly underrated. In a hot, dry climate, crawl spaces are the best place you can put your ducts. It's nice and cool down there. And you just don't see that as much as you should. I guess it's a cost of building the house that way, but yeah. And then, R8 is standard out here, on ducts. I think it's pretty much standard in most of the country, I think. And there was a comment about oversizing, having big ducts, and that might reduce your supply air temperature. It would have to be a pretty extreme case. The only time I've ever really seen that was when this one contractor actually strapped the ducts up against the underside of the roof deck. And so it was like, first of all, I was smashing the insulation, and the underside of that roof deck was probably 120 degrees. And so, the delta T from the time the air left the coil to the time it reached the register, it actually gained quite a few degrees. And that was a problem. But for the most part, it would have to be a dramatically bigger duct for it to actually change the temperature of the supply air. And of course, that depends on where it is too, attic or crawl space or whatever. But yeah, we're
a couple of comments. Brendan Reed, thank you I haven't seen you in a long time. Hopefully you're doing well. He got a whole thing about burying ducts. There's actually a variety of requirements or guidelines about how to do that, especially in the South, where you may actually end up with, a sweating and condensation that shows up, and you don't know it because you can't see them anymore. Well, I lived in Georgia for quite a while, and they do such an amazing job of trying to insulate their ducts, whether it's a crawl space or even attic, that they actually increase their air sealing, how tight the ducts are, because of how well they insulate their stuff. Sometimes the ducts can be leaky, but it all stays inside their insulation. May not get out of their your supply register, but they still do a good job. The other one I want to highlight, though, is the challenge of, like, even if you do a great job of your attic, we still keep moving our supplies to the outer walls, which is one of the hottest parts of the attic. Less insulation, higher temperatures, higher exposure. So you may do a great job of controlling the temperatures until you get right to the end, where you're throwing the air into the room, and end up with now I just increased the temperature because that's one of the hardest parts. Little insulation, and usually the boots aren't well insulated either. So if you want to be on top of your game when you have those higher temperatures that are there. So I'm going to go ahead and bring up another image that will lead us down two paths. Okay. And the issue is about registers and manual T. All right. And also, how are we throwing the air into a room? And this is a large part of the design. Sometimes it's almost impossible to adjust from an existing home, but this is the difference on great duct design. All the way at the end, only find out that you have a register that has very little airflow, or poor airflow, or they end up putting it into a location and have to add this plastic directional piece on it. So, Greg, why don't you start with some of the challenges that go along with, where does manual T make sure that your system is providing the comfort that you actually spend a lot of time on?
So I like that picture. With that, like, a lot of our customers are just like, well, I saw this on Amazon, or I saw this here on whatever website, and they want that. So can we incorporate that in our design? Probably not. But if we're able to, let's try to do that, whether we add a little more. But when we talk about manual T, it's really just how that air distributes within that room. So if we're not distributing the air through the room, you sit right next to that register, feels great. You go across that living room to the other couch or wherever, it's not going to work. It's not going to feel comfortable.
So do you ever think that you can go to a house and realize that, this actually is a really good design? Everything is working here except these registers were, stamp face or poor design. Is that ever like an option? But you know what? We could probably just change the registers out and actually get a better supply here, or get more airflow or a better direction out of that. I think
Oh
it's one
yeah,
thing. Yeah, some technicians don't even realize that they think it's the whole system is a problem when it may just be the termination.
yeah. It could just be that, or even just the noise that it's making. You can make it a little bit quieter by putting the right register in. Couple months ago, I had a customer that very contemporary house, and there's only an attic over part of the house where we were putting the equipment in, and his living room was 20 something feet away. So how do I get air from over here all the way to his other wall? And it's really just register selection, getting the right register that's able to throw the air, almost as far as I needed it to. And he's been comfortable since.
So before I switch over to you, Russ, I know you've actually got a couple of slides. We want to talk about this and how we supply air. Valerie with measureQuick, she had a question about ventilated versus encapsulated attic. So do you have any feedback on that, Greg? About if you really, for your own home, would you prefer a ventilated or encapsulated attic, and why does that make your duct system better?
Whatever's cool to work in, that's what I enjoy. So if I'm not working in 150 degrees, I'm comfortable. But
Yeah,
in terms of that, either or, really. It's just lowering that attic temperature and making it a little better for the ductwork and the person in it.
So to clarify, so a vented attic is what the majority of homes have. There's just vents usually either on the gable on the ends or down below and up high. That's intended to actually cool the attic or allow the shingles to not overheat, and a variety of reasons why we have vented attics. But encapsulated, you're trying to what I see is, I'm sure others have, is they have this encapsulation where they put a bunch of spray foam in. I'm not going to go down the spray foam path, and then they find out that people still vent them, right? And you're like, wait, you did one thing and then you then compromised it by doing something else. With an encapsulated attic, you actually took your insulation and R value and went from the ceiling to up high. So I now don't have so much radiant temperature coming in. And when done well, they actually can make your duct systems really pop. So yeah.
Yeah.
So I want to go ahead and spend a few minutes about register selection and where you are supplying your air. So whenever you want to, Russ, why don't you go ahead and bring up some of your slides? And
Yeah, I wanted to mention too the little picture you had of the floor register with the plastic thing. That's pretty fancy. I wish I could show you mine. It's actually a shoebox with the end cut out of it sitting over my floor register, because when my air conditioner runs, the air blows under my desk and hits my knees, and it makes my knees sore. So I being a mechanical engineer, of course, I took a shoebox and I cut the end out of it and I set that over the register so it blows that direction. So,
but it does bring up one challenge though, so that you may thought you had a great design, and people are like, well, that's actually where our TV is going to go. That's actually where the couch is going to go. So exactly. There are great opportunities if you're coming from below in the basement, only to realize that, I probably should do the middle of the floor, even though people don't like that. So
yeah, and floor registers are a real challenge. That you almost have to go to the perimeter with a floor register. It's very difficult to get a floor register to blow across the room to the opposite side. But when you're talking about ceiling registers, I will share my screen. When you're talking about ceiling registers, I have what's called the 4 schools of thought on ceiling registers. And I was actually a participant in a very, very scientific study that evaluated these 4 options. And I'll tell you the results at the end. But and the other funny thing is, when I teach manual JS&D classes, one of the very most contentious topics that people will actually get upset about is where to put a register in a room. And I've had people in class like yelling at each other, saying, "No, you're an idiot. You don't know what you're talking about." And, "Oh, you insulted my family heritage by telling me I'm wrong." And, they just get all bent out of shape. But it's interesting because, so if you look at a typical room, you have a side view here on the left. I don't know. Can you see my cursor if it's moving around?
I cannot.
How about now?
Oh, there you go. There it is. Okay,
Okay.
it's just delayed.
Okay. So this is a side view. So here's the door over here, and here's the window. And this is rule of thumb or school of thought number one, which is to put the register out over the window. Well, first of all, if you do that, it really, really needs to be a two-way register blowing in two directions. I've had people blowing registers directly on the window, and all you're doing is forcing heat through that window, or blowing back into the room, and then you're just blowing it towards the door. One of the rules of thumb I try to use when I can is blow the air the opposite direction that it wants to go. If the air wants to go out the door, blow it away from the door, and so it has to collide with that air, and it mixes better because it's all about mixing. But anyways, you've got the register over the room. This light blue is what I call the primary airflow. That's the air coming out of the register. It has momentum, it has velocity, and it shoots into the room. But at some point, it loses that, right? And then what happens to it? Well, then that's the purple arrow. I call that the secondary airflow, and that's the air just kind of being pushed slowly out of the room because there's more air coming in behind it. Okay, so there's really two kinds of airflow you have to worry about: the primary and the secondary. And so this is looking down on top of it. So the primary air is coming out, shooting across the room, and then the secondary is the air kind of moving out the door. So that's the first school of thought. The second one is interior to the room, blowing across the room towards the load. Okay. And that should either be a three-way register or a one-way register. They actually make one-way registers too. And so it's blowing towards the wall, but then you have to worry about throw distance and making sure the air is not stopping halfway across the room. And then you get stagnant areas and stuff like that. Okay. So that's school of thought number two. School of thought number three, you don't see that much, but it's actually by far the most common way of doing it in Las Vegas. In fact, any house that's built in Las Vegas, I guarantee you walk in and there's gonna be a square register in the middle of the room. And it's just how they do it. And I got several answers as to why that's the case. But it's kind of nice in that you're dispersing the air in more directions. So you get better dispersal, you get better mixing and things like that. But you also have to worry about short circuiting the air. And if you blow it towards the door, it's just going to go right out the door and it's not going to help the room at all. All right. So that's the second school of thought, or third one. And then the fourth one isn't actually a ceiling register, but it's close to the ceiling. And that would be a high sidewall register. Okay. So it's blowing across the room. This is a different type of register, a different type of grill. This would be a bar type grill and not a directional grill. So you want it to blow straight out. Okay. And so we did a very scientific study. We rented this supercomputer and these very smart people did this, complex finite analysis. I forget what it was called. And they evaluated these four options in terms of comfort and energy efficiency. Okay. And in terms of comfort, they were all very, very similar. The one that was a little bit better was the high sidewall register, was a little bit better in terms of comfort. Finite element analysis. Thank you, Ben. It's been a long time. It's been about 15 years since that study. Yeah, the high sidewall register was stood out above the other three, and the other three, whether it's out over the window or back in the room or centered on the room, were really, really close to each other in terms of comfort. Now, the register out over the window was the worst in terms of energy efficiency because it had the longest ducts and there was more heat gain because of the length of the ducts. Okay. And so those really interesting things came into play. And it was kind of a fascinating study. And so what I tell people is it doesn't really matter where you put it as long as you use the right kind of register and as long as you account for that extra length of duct. If you forget that that's there, you might not get enough airflow. But if you account for it, and it all comes back to that friction rate number, you'll get good airflow and you'll get good mixing. And again, this is all dependent upon proper sizing. Okay. If you oversize your equipment, it's going to short cycle. So it's going to blow really cold air. I'm talking about air conditioning, obviously. It's going to blow really cold air into the room for a little while, and it's going to stop. And then that air never mixes. It just kind of sits there. And that's when you start getting problems. But when you have properly sized equipment, you get these nice long run cycles, and the air will mix and it'll have time for it to mix with the entire house, and it passes through the system several times. And then where you put the register has much less import than if you were it would oversize the equipment and have short cycles. So it's kind of an interesting study.
Maybe your Vegas example is because it's a major cooling dominant
Yes.
process where they really want to get that cool air on top of me and get dehumidification from my body and everything. So that may be one of their solutions was I can feel the cold air right on my where I'm at. So
Yeah, one of the best reason I asked a contractor, I go, why do they like square four-way registers in Las Vegas so much? And the best answer I got was, he said, my guys can't screw it up. He said, no matter how I put it in there, it's always pointed in the right direction.
Yeah, that's good. That's good. One of the things that I know you have a slide on, I just want to kind of like just do it is so for people who don't know, people are very familiar with Manual J. That's the BTU requirements for either individual rooms or block load. Last week we had a conduit on with Shelby, and she described these similar to what you had as your new app that does measurements. Hers does something similar and actually calculates your total Manual J. And there's Manual D, which is our duct design. S, we're going to skip that for now for S. And but the other one is T. A lot of people forget T, and some people will work backwards from what my T is now determine some of my duct runs. So can you show us some registers and why T is such an amazing value for what you just showed us these different places to put the register, but doesn't mean that same register actually will work in all those conditions, whether it's on the floor or the ceiling or the wall. So explain why T actually makes the difference on comfort.
Yeah. So these are your three basic types of registers that I see most of the time. I've seen round registers. I've seen all kinds of weird stuff. But this top one here is like your lowest end stamp face register. And they call it a stamp face because it starts off as a piece of metal and it just gets smashed and the fins get bent out and all that. So this is your low end stamp face. In the middle is what I call a bar type register. Each one of these fins is an individual piece that fits in there and can be adjusted. And then at the bottom is a curved blade stamp face register. The one in the middle, you can just look at it and see how much more open area it has. And what Manual T is really important about is it tells you to read the dang manual, right? It says this register has some specs. And if you actually open up the manual and look at this table, it'll tell you how much air that register is designed to put out at a certain pressure drop. And that pressure drop is actually used in the Manual D friction rate calculation. So when you plug that number into your friction rate, you're saying, I'm going to pick a register that's going to have no more than this pressure drop. How do you know? Well, you got to go look. And so when you actually open the specs for these three different registers, this register in the middle for the exact same size register as the one on top can handle twice as much airflow. This register in the middle can handle twice as much airflow at the one above and have the same static pressure drop and a much better noise criteria too. That's the other thing is the NC, the noise criteria. And then the one on the bottom is kind of in the middle. It's good. But then the one in the middle, because the blades protrude down, they can actually curve the air and have it flow more parallel to the ceiling and get a better throw distance. So when you look in the specs for a register, I mean, you can go down a rabbit hole pretty quick, but there's noise criteria, there's throw, there's CFM, and there's static pressure. And all four of those things affect the performance of these registers. And so it's really interesting to put these in a system where they're all getting exactly the same amount of air going to them, the same size duct goes to them, and then measure the difference of static pressure drop as you go through there. It's interesting how much pressure drop there is from a register. When I was a bachelor, I lived in this it was an apartment on a farm somewhere, and the air conditioner didn't work very well. And so I went around, I took out all the registers, I just took them off. And so it's just a register boot in a hole in the sheetrock blowing into the house. Made a huge difference. It made a big difference. Take a register when the air conditioner is running, like a floor register. When the air conditioner is running, pull that register out, and then slowly put it back in to the hole where it came out of, and you'll feel that air pressure pushing against that register, and that's pressure drop across that register. It's pretty substantial.
Thank you for sharing. That's I think it's the most forgotten thing that people have in their house is, they realize that the register probably is impacting their comfort. So.
Yep.
Okay, I'm going to take you guys. We're going to bring your thing down. We're going to switch. So, HVAC to home performance. My buddy Jeremy Begley is out there, or somebody from him is saying, what are airflow considerations when going from a gas furnace to a heat pump? And we talked about this in our meeting right before, and the challenges with heat pumps, and airflow is now critical. And so, Greg, why don't you talk about when you guys are going to heat pumps and for somebody's furnaces? We'll hold off on the conversation you got to have with the client, but let's talk about your design criteria and what you might have to do to your ducts, or what is it you guys are looking for to find out, is this system going to work with a heat pump?
Yeah. So if it's going to work with the heat pump, we're looking right at what size ductwork is existing. What is it neck down to? Like how we were talking, like if you have a drop coming down in the basement to where that furnace is, and that drop is enough air, but you go up top and it's just a small little pan bay, is that enough? I've noticed a lot of our retrofits where we're taking out a gas furnace, propane furnace, oil furnace, whatever, and put in a heat pump. That's where we're losing our airflow. And that ends up getting the callbacks, the customers calling saying their electric bill is sky high, and all the complaints of just comfort and just spending more money than they used to.
So let's go to, if you're going to do this swap out from the furnace to the heat pump, let's talk about what are you communicating to your clients so they understand how these things work differently. One of which we've been instructed to always turn our thermostats down when we leave the house or at night. And it's just, we're in grade school, like, oh yeah, turn your thermostat down. So that's one of your communications, but what else are you communicating to your clients about what they should expect from a heat pump versus their furnace?
Yeah, so never touch the thermostat, basically. Just set it, forget it, don't adjust it every day. But one of the biggest things are that sticker shock of January, February up here in New York is the coldest months. When they get that electric bill, it's going to be ugly. That electric bill, January, February, even in my own house, that's my highest bill that I see. Then as soon as I get back into spring and summer, it evens right out. And I end up saving more in propane, or the customer would save more in oil, just if they look at the year in the whole, as a whole. Some of the other stuff is set it to where you're comfortable. Some customers are setting the thermostat at 65 because that's what they're used to, or 68 or whatever. But with the heat pump, now we're blowing a little colder air than that forced air furnace, the oil furnace. So now 68 and 68 is the same, but maybe you're more comfortable a little higher now because you used to get all the air blown right on you, and now it's a little cooler.
Yeah, I think the supply temperatures are a shock, literally, to many of clients, that they're expecting this super hot air that they've always had their whole life, and now suddenly that's not the case. And I know a lot of people that are doing sales, and whoever does their final explanation aren't communicating what they should expect. There's other stuff with noise and whatever, but in general, if you really didn't explain to them, and builders will do this and not explain to their people that are buying their homes what they should expect. So yeah, it's really a challenge.
And if we're bragging about electrification, saying, hey, it's going to be the best thing ever for your home, and then we don't give them the right ductwork or the right system, right size system, and now their bill's sky high, they're going to hate that purchase. They're going to complain, say it was a waste of money. They should have just stayed with the original fuel source. And they probably were better off that way if we didn't update the ductwork.
Revolt, it's coming. It's coming, right?
I like to ask homeowners, what would be the perfect HVAC system in your house? Like if you could dream of the perfect system, and most of them would say, well, I just want my house to be comfortable. I don't want to hear it. I don't want to feel it. I just want the house to always be comfortable at the right temperature. And that's a heat pump is actually closer to that goal than a furnace is, because a furnace, people have just been conditioned to say, I want to hear it come on so that I know it's running. I want to feel warm air coming out of the house. Well, that's not what you just described as the ideal system. The ideal system, you just don't want to feel it. So if you get a heat pump, and a heat pump's going to blow air into a room that's closer to the room temperature than a furnace is, so it should be less noticeable than a furnace is going to blow blazing hot air into the room, right? And a lot of people say, well, it's blowing cold air. No, it's not. It's blowing warm air. It just feels cold because it's not as warm as your body temperature. And I like to explain to people that you can heat a 70-degree house with 71-degree air. You can warm that house up with 71-degree air, but you don't want to blow 71-degree air into a house because it's going to feel really cold, right? But we're blowing warm air into the house. So that, again, it gets back to manual T, right? You just don't want to blow that air on people so that they feel it.
Well, there's what's really the highest level is what's my radiant mean exposure that people are having, so that it is the air coming out of the register. It is also the walls and the windows and a variety of stuff and what's in that room. So the real challenge for HVAC contractors is that you're supposed to fix all other problems that my house has. When my I have R13 walls and pour ins and windows. Well, you guys should just figure out how to fix that. So you can just make me comfortable in your, that's a whole nother topic about, all the envelope and home performance that is out there. But in general, that's one of the challenges is that they think that your systems just overcome all their other problems that are much more larger to fix than just a new system or supposedly this heat pump. So.
Yeah, which is all the more reason to be a home performance contractor instead of just an HVAC contractor, right? When you're a hammer, everything looks like a nail. When you're an HVAC contractor, everything looks like an HVAC problem. So you try to overcome it with HVAC problems when the problem might actually be the house. You may need to insulate. You may need to do some things to the house to make the problem better. So, yeah.
And I think that people are reluctant to want to take that on because they're very comfortable with the guys they've got, the people they're working, their whole team is working well. And but there's partners, there's people out there that you could, sub this out. Many companies have, plumbing and, electrical or whatever. I think that's just one more side to that. So I don't know, Greg, so I'll kind of throw that out to you. So are you guys doing home performance? Are you working with somebody? How do you address the worst issue, which is the dang house itself?
We don't do anything in-house. We have a couple contractors throughout the years we became or got really good relationships with, so we trust referring them, bringing them in. We found a restoration company that they're able to do a lot of the stuff a lot of other companies aren't. So they are looking more into the insulation and making sure, like, even if they're re-insulating something, make sure there's no like growth or anything behind the wall that's already existing. Because if there is, then we didn't do it. So
Right.
having stuff like that helps. But really, just syncing up with the contractor that we could trust who does the same quality we're after is the big thing.
So I know one of the greatest challenges that when I talk to a lot of contractors, they're swapping out a system. They're able to downsize it. They were able to go through that scenario, and then it comes to the reality that, especially for a heat pump, that this ductwork is too small. This 12 by 12 trunk running down the middle of the house is not going to accommodate the amount of airflow that we want to get to you. So, and you now just increase that price significantly, and they're like, nah, I can't do that. Now the deal is done, and for some reason they go to somebody else. They're like, oh no, your ducts are fine, and they found out that it wasn't. So, Greg, how do you do this conversation with a homeowner about why? And most people think that you have to do this in one shot. I don't. I think that you can be like, you know what, we don't think your ducts are large enough, but we can install the system and see if it will accommodate what we need. And if not, I'm preparing you now that we now need to come back and reevaluate that or try and do it all at once. But I think that there's a conversation that is really awkward and a lot of people skip it. And they find out at the end that they should have talked about this with their client. So how do you guys handle the sales process when you know your ducts are either too small or could be too small?
It's just given the options. Like if you walked into McDonald's, you have the option of making it a full meal or just getting the sandwich. If you choose you want the full meal, you could always go back to the counter. And that's the same thing with us. As long as the customer has the option up front, like here's the heat pump, and then here's the heat pump with the ductwork. If they choose just the heat pump, you get the little "I told you so" next year because their electric bill's high or they end up needing to do it. But at least you were on paper and had it in front of them, and offer and let them decline it is the big thing. There might even be stuff we could do in the meantime. Instead of the full supply duct or return duct, we could do minor stuff. We might be able to just cut out some flex because they use 25 foot in one run. We could trim some back and do some minor stuff to help.
That's great. So, Russ, do you have anything to add about how you communicate with clients about these decisions that they're trying to make with ducts that are undersized?
Um, Not so much the ducts. Well, yeah, I mean, I especially when going from a furnace to a heat pump, I really push hard on improving the house first, reducing the load of the house first, and then if you can downsize, you might actually downsize your equipment to where it's actually closer. Your ducts are closer to being properly sized now for a smaller piece of equipment. Um, so yeah, it's reducing the load first is a huge deal. I mean, I talked to a contractor who said, yeah, well, we did this house. We did the loads on this house that had no ceiling insulation. It was R0 ceiling. And we did the loads on the house and it called for this size equipment. I go, wait a minute. You're sizing the equipment for a house that has no ceiling insulation without recommending that they install attic ceiling insulation first. They go, yeah, well, that's what they had. Well, that's not how you should do it. I tell people, don't design a system to a crappy house. If you design an HVAC system to a crappy house, it's going to be a crappy HVAC system. You got to make the house better first. You got to get it as good as you can, and then size it or I should say, as good as it could be, and then size the equipment for that. And then what you'll find is that the system may work fine, and then they always have the option to improve it later and bring the loads down to what it really should be and save money, but it'll still be comfortable for most parts.
Well, what the other thing that happens sometimes is they will improve the home performance and then realize that they're now comfortable and they may not really actually need a system. They're actually, wow, I didn't realize how great my home was once I actually, improved air sealing and added some insulation. So that's
you got to install the new equipment before they discover that.
Yeah, right. Get your down payment. So
yes, exactly.
So let's go with one of my kind of ending questions here is what are some of the most common design flaws that you see people doing, Russ, and how can you give some brief advice as to, here's 3 things you must do and 2 things not to do or something? Because I know you see a lot of people that you all thought that they knew what to do and found out that, wow, that was a bad path.
Yeah, it's the most common design flaw that I see is not doing a design, honestly, is rule of thumb. 500 square feet per ton is not a load calculation. I'm sorry, it's just not. And then sizing the ducts by rule of thumb, saying, oh, it's a bedroom, it gets a 6. Well, I've seen bedrooms right next to each other, where one needed an 8 and one needed a 6. The one that needed an 8 was on the corner. It had 2 windows on 2 sides and they were facing southwest. The other one had a window facing north or something. Same exact size room, but one needed a lot more air. So you got to do that room by room load calculations to size the airflow to the room's load, not based on the size and type of the room. The other thing I see a lot of that's a big problem. We sell software, and so we get a lot of people buying our software, and they have a lot of tech support questions. Well, one of the biggest mistakes people make is they try to learn HVAC design at the same time that they're learning a new software. And that's tough. That's really tough. You really should have a basic grasp of manual JS&D first. ACA, Ed Janowak has a great basic introduction class to manual JS&D. You gotta have a basics first and then learn a software. Otherwise, you're learning 2 things at the same time. So it's kind of like learning how to use a saw and learning to be a carpenter at the same time. You should learn to use a saw first, or learn to be a carpenter first. Learn the basics. Whatever. My analogy just fell apart, but you get it.
How about you, Greg? What are things you're seeing from either design or even install, or things that are just from other companies you walk into, or even how to correct and make better for Jones?
I think the biggest thing is just focus on return. Like, everything's important in that design, but if we don't have enough air going to that system, the supply doesn't really matter that much. You're not getting the air over the coil. So focus on the return. I'm always just trying to get as big of a return I could physically fit in that spot. So if I'm able to do 2 16s on a 2-ton, I love it. Or 2 18s on a 2-ton, 3-ton, whatever. The more air I get through that system, the better. And it also helps with filtration in the house. You're moving that air slower over that filter. You're able to get a bigger filter sometimes with extra returns or bigger returns, and you could get more dust out of the air and keep that coil cleaner. So less maintenance, less of a chance of that drain line plugging up and just causing issues.
Yeah, we're going to do a separate webinar on filtration alone. I kind of avoided that as people kind of caught on as we got to this point that filtration is a whole nother level and challenge that goes along with that, and static issues or just poor performance in general. So we'll come back to that as a separate topic. But there are trying to think what are some of my other topics. There's a few people that chimed in over there in the South. Any I guess final questions for the presenters, to everybody out there? I'm looking through it to see if there's anything else we want to deal with. But I guess, what is your number one advice for those who are listening or want to be, realize that this is actually something, and most times most technicians, this is not what they're thinking about or focused on, or even the salespeople, it's not something that they really are walking into the house instantly looking as this is supply at the ceiling or floor or some of the conditions. They look in the attic, they go to the basement or look at the crawl space, and I don't think they really are paying attention to what are the details that have to be accommodated here. They're usually more like, okay, I need to get a load, and just kind of trying to find out what it is I need to design. So what's your advice to people is how do we make systems? Oh wait, there was one that I was looking for. We didn't talk about testing, and there is a whole nother webinar on testing, but it's one thing to do a duct leakage. It's also a thing to measure what comes out of the registers. So there's a variety of stuff that happens with the testing. So I'll jump to, sorry. What is your belief about why I should test my system after I'm done, Greg?
Just to see if it works, see if it's performing how you designed and what you wanted. And with testing, there's a bunch of different tools you can get. On the less expensive side, you can just get a manometer, check static pressure. Start there, simple, basic. Get a little fancier, go to the TrueTech Tools has it, the TrueFlow Grid. You can get that, throw that in, and that steps you up another notch. And it's pretty cool for a homeowner to see that report at the end, going through measureQuick, showing the commissioning process, how you pulled the vacuum, how you pressure tested. That system's nice and clean. Now, all that report is done on day one, and you can prove to the customer, here's what you paid for. This is why you paid more for me rather than whoever up the street.
Yeah, so some other, go ahead, Russ, go and add to that list of stuff that people can do to confirm that everything was operating correctly.
Yeah, Greg nailed it. It's, the most important thing of airflow is the airflow across the coil. That's what you want that's your total system airflow. That's the most important number. After that, it's where's the air going, right? If you're putting all that air in one room, it's not going to do much good, but at least you'll be getting your full capacity out of the equipment. You won't have good air balance, but then the next thing is where is it going, right? That's the air balance part. That's important. Static pressure is such an easy thing to check. But if you want to actually measure airflow, you really should measure airflow because static pressure it's a good indicator, but it's not a good way to try to determine actual airflow. Even if you went back, even if you had the table for that particular air handler, the way you measure static pressure can vary a lot too. So, but yeah, airflow. And then you mentioned leakage. Leakage can have a big impact on pressure issues. I've had some really weird things happen in new houses where like a duct became disconnected and actually it created a negative pressure created a negative pressure in the house and sucked air down the wall and blew hot air on the back of the thermostat. And it just went bonkers. And it took us forever to figure out why it was doing that. And so, yeah, duct leakage is a good one. That's all I can think of.
So I was a home inspector for many years, and I would do a basic temperature split, even with the little IR, handheld thing. It gave me something, and I actually used a stick with a little, piece of paper or flag on it, right? And I just went around to make sure that air came out of all the registers, right? Because I did find many registers that, and you may think that all your guys did a great job when the people did a great job when they installed it, and then. Somebody else came up and added insulation or did something and kicked it loose. And those are the kind of things that you may not notice, especially if it's not the main bedroom, where they would have kind of caught that pretty quickly. So there's just more and more parts of a lot of stuff happening. So that brings us to what's your takeaway? What is it that you want people to really understand about why the design and the airflow are just makes your system complete? Greg, why don't you go ahead?
I think just focus on the ductwork itself and what that customer is expecting. Make sure you're on the same page of what you could provide versus what they're expecting to get by giving you that check.
Russ?
Yeah, I would say if for people learning to do design, first one, number one, do design, right? And then for people who need to learn how to do design, don't get hung up in the details. I have an expression I like to use: don't waste time splitting hairs, because our job is to shave heads. We have lots of heads we need to shave, and you can get really lost in the details. But if you do a decent design, you're going to be in the ballpark. You're going to be close, and it's going to be so much better than using rules of thumb. The other thing is, if you're a new designer, don't design in a vacuum. Talk to other people, talk to other designers, find a Facebook group where they talk about it, share your designs with other people. And then the absolute most important thing, if you do a design on a house, you got to get out there and measure it and see whether it's performing how you thought it was going to.
Yeah.
That feedback is the most amazing way to build your confidence in your design. Is that I designed it to do this, and oh wow, it's actually doing that. Oh my God, it's actually doing what I thought it was going to do. It's a huge boost to your ego when that happens.
So I want to go a couple of plugs here. So one of my slides that I do whenever I train actually comes from Greg and his team. That they have several people that adopted measureQuick on their own. They didn't make it a mandatory, so those are always determining, do I make all my people do this or not? Well, Greg and his team decided, yeah, if you want to do measureQuick, let's add it. They kind of brought it in slowly, and some of their technicians used it on every job, and many of them had increases of 60%, and even now even higher from the year before. Every year they have an increase of actually the things that they're finding with measureQuick, from airflow problems and other conditions automatically, and that only leads to going to existing homes and finding stuff that they need to talk to their clients about. And again, 60% of your pay, what you're charging per job, and all those goes up. That's a noticeable amount, and he was thrilled that his pay increased, around 60%, and it's only gone up from 22 to 23 and more on. So I really appreciate that you guys are allowing your team to discover measureQuick, because when you discover yourself, it allows you to push on to something else. So the other plug is Quick Model. If you're not familiar with Quick Model, I'm sure you can Google it and find that. It's a phenomenal resource and really fun to actually use. Maybe you can put some gaming music on in the background and do some design. Next week here in Colorado is the Heat Pump Summit. All right. Brett Davison puts on a phenomenal opportunity for bringing some of the best trainers, not just in Colorado, but across the country, to talk about what is your heat pump challenges, from design to install. I'm doing a whole session on commissioning, and there's a pre-conference this on Tuesday that's focusing on the business model. What is it that your company can do for that? So I think there's a banner at the bottom talking about where it is and when it is, and there's a discount if you want to come out to that, or probably going to figure out a way to get you in for free. So this is only going to grow in terms of the more information that we need to get out there. Collectively, we all know more than one individual. That's why we're trying to bring on experts every week to talk about each one of these parts, about where heat pumps could fail. And we don't want the revolution of 2027 or 2026 or even later, or whatever, to happen anytime. Is the last thing we all need as an industry. We really need to figure out a way to do this, do it right, and do it well. We all win when that actually happens. So Greg and Russ, can't thank you enough for everything you're doing here. So I'm sure we'll have you back in the fall to reevaluate some of the conditions that people are asking about.
Cool. Sounds great.
And thank you, Joe, for hosting us today and having a wonderful discussion with our two experts. And thank you to all of the audience members that were able to attend. Please share this video with your network. The live stream is recorded on YouTube. You can rewatch it whenever you want. And we're going to have more of these webinars soon. Next week's going to be pretty busy with our events that we're participating in, so we might not have one next week, but just stay tuned to our event page on our website, and our social media will announce things on both of those locations. So
what I did not plug was I'm actually doing a measureQuick training the day after the heat pump at the same place as the heat pump. So if you're coming out for the heat pump, don't hesitate to stay for one more day. It's a 4 hour let's learn measureQuick right there. That's your QR code to learn more about that. So we want to, as I say, spread the word of measureQuick. So whatever you can do to learn more about measureQuick, and we'll have more trainings as the summer goes. So Yeah, this is awesome. And Ben, well done. Always well organized. People don't realize what all happens in the background and how well we all show up and look great, because Ben actually pushed us into organizing ourselves before we actually got on the call this morning.